Hey, what's going on, IB Math AI students? Today we are back into geometry and we're looking at distances in three-dimensional space, lesson number 7. Your EQ for today is how do right triangles help us find distances and angles in solids, so let's jump right in. Now you may be asked to find the distance between any 2 points in a solid. These points could be vertices, they could be midpoints, they could be any combination between these two as well, so you got to be flexible. Now, sometimes these points aren't given to, or they're given to you as an ordered pair. So you've got your coordinate plane and you're going to be told that these points are in some coordinates x, y, z. All you need to do is apply the distance formula. Now, that distance formula, as we have seen in the past, you can also expand that if you're looking in 3 dimensionals to include your z2 minus z1 squared. That's all. You're just including that extra little bit into your formula. So all you need to do if you're looking for distances and you're given ordered pairs and coordinate planes, just find the distances using that distance formula. Just plug it in. Most oftentimes this is not the case, and you're going to need to identify, this is the most important part, what we are looking for are right triangles. We love right triangles because we can utilize things like the Pythagorean theorem. We can also utilize trigonometry. So let's take a look at an example of how we can do this. The diagram shows a cuboid or a rectangular prism to the right, A, B, C, D, E, F, G, H, and we want to find the length of a few of these things. First one's going to be super easy, right? AH, like there shouldn't be any problem with that because we can recognize, okay, there's a diagonal connecting those two. They're on the same face, and we can go ahead and make ourselves a nice right triangle doing that. So that should be very, very easy for us to do. AH is simply going to be the square root of this length 7 squared plus the height of it, which is the same as this one here, and that's going to be 3. So we say that AH will be square root of 49 plus 9, and that's going to be the square root of 59 centimeters. Easy enough. Now, that one, not a sweat. Let's take a look at another one, though. Now we want to go actually through the solid, and that's where we get a little bit tricky, and it gets hard to draw these things. So AC connects the bottom face is what we're looking at. So we're going through the bottom face now. And now we can see that, oh, I still have a right triangle connecting these two. And now we're going to be looking at AC is going to be the square root of 7 squared plus 4 squared. Those are the sides that make up that one. So that's going to be square root of 49 plus 16, which is going to be the square root of 65 centimeters. Finally, we now get into AG. So AG is not on the face at all. It's from one corner of the box to the next. So this actually goes through the solid. So how are we supposed to deal with this? Well, again, what you're doing is you're looking for right triangles. Well, what if I connect it down to here? Connect that bottom face to that line. And that's actually really handy because what did we do in the previous one? We found what AC was already. We knew that was square root of 65. So that's easy enough. And now we also have here 3 and 65, square root of 65. So we can go ahead and find AG. So AG is going to be the square root of square root of 65 squared plus 3 squared. We can go ahead and find that. AG will now be the square root of 65 plus 9. And AG will be the square root of 74 centimeters. And now you found all 3 of those. So again, why did we need to find AG after AC? Why couldn't we have found AG right away? Well, we needed to have that value AC. We needed AC to make a leg of a right triangle. Where AG is the hypotenuse. So angles between two lines, or between a line and a plane, are really just like working with the lines in solids. You first want to identify any right triangles that you can work with. After that, you just need to use trigonometry. The first challenge usually is actually recreating and drawing the picture and finding the right angle. So let's practice with that. In the diagram, E is vertically above the middle of the base. So we have a pyramid here, and it's a right pyramid. We want to mark the angles as described. So we want to mark the angle with the base ABCD. And then we want to see that's going to mesh with edge DE. Okay, so go ahead and practice drawing this shape on your own. We're going to zoom in on this and recreate it. I'm going to teach you how to actually make that sketch. Start off with the base, and the base was kind of a parallelogram here. Estimate about where the center of that is. Go ahead and mark it. Then go ahead and label your points. We had A, B, C, D. E was directly above, so try to draw a perpendicular line going up to point E. And now connect each one of your vertices to that point. There's AE. There's that one. There's that one. And there's that one. So now what we want to do is go ahead and try to mark out the two different parts that you want to work with. Base ABCD. So you want to think about it. You're making this space here. Okay? And so that's a flat part. Okay? So think about from that flat part and then the edge DE. What's the angle that's being made with that flat part? Okay? So try to draw a line that's going through that plane. The line connecting D and O is on that plane. And that's what we want. We want to have another side or another length that's going to be going through that plane, and then draw your vertical. And you can see, oh, look at that. Now I've got my nice right triangle right in here that I can work with. But the angle that we're interested in is the angle that's made from that base, trying to extend it up through DE. And there it is. That is the angle that we want to be looking for. So I'd like for you to try to do the same thing with part B. When you come into class, let's check your work. Now that you've had some practice with that, let's actually put it into practice to find that missing angle, not just drawing it out, but finding it. So the diagram for number 3 shows another rectangular prism, a box. We've got a few different lengths here given to us, and we want to calculate the two different angles. So I'll do one, you do one. Let's take a look. Okay. So the first one that we want to do is calculate the angle that the plane ADHE, this here. I want to calculate the angle that's made with that and the line AG. So I'll draw that connecting part. Now, the temptation might be to draw this. But that's not really the right triangle that we're going for here. That's not the angle that's being made. What we actually want to do is try and make one of these a very obvious perpendicular that's already there, and that's GH. This is going to be the angle that's made between those two. It's like the most direct lines that we can actually draw. So that's what we're trying to find, and we want to find this angle that is made here. Now, we know this is 2. We know we have 9 and 5 as 2 of our sides, but we don't have this one. We need to find that one, but that's easy enough for us to do. We know we can do some trigonometry. So AH we need to find. We'll find AH, first of all, by taking the square root, 5 squared plus 9 squared. I'm just going to evaluate this without my calculator, and I'm going to say that's going to be 25 plus 81. And that's going to be 104. So that's going to be square root of 104. Go ahead and write that in if we want to. Now, square root of 104 and then the side 2, we can find Now, everything that we need, we've got an opposite side and we have an adjacent side. So let's go ahead and utilize our trig. Opposite and adjacent tells us we should be using tangent. So we have tangent of a angle HAG or angle A, but let's go ahead and actually write it out. This is HAG. And that's going to equal our opposite side 2 over the square root of 104. We know we need to take the inverse tangent of both sides. So HAG will equal inverse tangent of 2 over square root 104. And we can come over to our calculator. There we get our solution. It's going to be 11.095 ... but we know that that is going to be just approximately 11.1 degrees to 3 significant figures. Your task is to find now the angle between the lines BH and HE. Try that one on your own, and we'll check your work in class. Thank you guys for watching. I'll see you next time.